Okay, so on Friday we just talked about how to divide out polynomials, long division, synthetic division, because the goal here, where we want to end before we have our test this week, is how do I divide out factors? How do I find factors in a polynomial? So the remainder factor and the factor theorem, remainder theorem and factor theorem, they kind of go together. So it says if you have a polynomial divided by x minus k, this is like, no, don't look at the answer. I forgot. I told you this isn't working today. This is like our synthetic division, right? It's written perfectly for synthetic division. The remainder will always be. It's rough. It will always be whatever f of k is. And what that means is you don't actually have to do the division to do this. Like if you just plug in k into the function, the remainder is whatever you get when you plug that in. So let's go back to the last example that we did, this one.
1.
What would k be in this problem? -3. If you would have done f of -3, if you just plug that in here, which is really nice with the calculator, right? Guess what you're going to get? The remainder, which happens to be 1. I'm really having some smartboard troubles today. So I can do the math if you want. -3 to the 4th is
A lot.
81.
A lot. Yeah.
3 to the 3rd is 27, and 27 times 3 is 81. And then 3 squared is 9 times -10 is -90. And then -2 times -3 is +6, and then +4.
1.
So that gives you 81 plus 10 is 91 minus 90 gives you 1. So if you're just looking for the remainder, you don't have to do longer synthetic division. The remainder is what you get when you just plug that number in. Why do we care? Because the factor theorem says if you want a factor of a polynomial, it is only a factor if and only if, right? That's what IFF means. I gotta go back because my smartboard is not pretty smart to me. It only is a factor if the remainder is 0. So these are like buddy theorems of they have to, like they kind of go together. It's very nice because if you're trying to find factors, you know that you don't actually have to do the division. You can just plug it in. How do you know when you found a factor? If the remainder is 0, or if you get 0 when you plug it in. Any of this ring a bell to you?
Sure.
So, what we didn't get to Friday that I hoped to get to Friday was, it says, use the remainder theorem to find the remainder when f of x is divided by x minus k. So, could you do division here and I would never know? You could.
That's what I do.
But the remainder theorem is supposed to be a quicker way, right? And so think about a test of you want to try to do things as quickly and efficiently as possible. Instead of doing long division here, you can just plug 2 into this problem and think about what factor we're thinking about here. If k is 2, then the factor is like x minus 2. So basically it's like we're checking, is x minus 2 a factor of this? Well, I can check really quickly if I just... I really need to restart my computer, but I don't want to because when I come in the morning, I open up all the windows I need for the day, and I'm just trying to get through the day of dealing with this, but
It's only second hour.
it's only second hour, and I'm ready to punch it already, so I might have to just shut it all down and reopen all those windows. If I plug 2 in there, and this is where when you have a calculator, right, it's probably way faster than doing division, and maybe way more accurate than making mistakes with your signs with division. But you're just plugging it in. So if I plug 2 in there, 4 times 2 is 8. Minus 6 plus 1, which gives me 3. So is x minus 2 a factor of this polynomial? No, because this is not 0. It's only a factor of that equals 0. This doesn't ask me that. It just says, what is the remainder? The remainder is 3. Draw this one. 1 minus 5 is -4.
I thought that equal sign was a negative sign. Never mind.
-4. Also not a factor because it's not 0. But if it just asks you for the remainder, that's all you're doing. Without doing division.
It would still be no, because you would do the exponent first, it'd still be 1, and then you have -1, because the negative's outside of the x.
True story.
So it's -6.
That's
Except
what
it's negative sign.
If it was negative x to the 4th, it would be -1 because you do the exponents first and then the negatives on the outside.
Oh, I think like the K. I think like you probably was -1 this K.
Oh, yeah. That's why I was like, still.
Okay. So, what if they ask you, is it a factor? So instead of giving you the k value, they give you the factor. Could you do division to see if it's a factor? Yes. Is there a faster way?
Probably.
What could I plug in there to see if...
-3.
So, the big difference between these two examples is on these two, they give you the k value. But if they give you the factor, you have to know that you always have to do the opposite sign of what's there. So you can plug in -3 here, and if you get 0, that means there's no remainder, it means it is a factor.
So, what if it's like an x squared plus...
Then you'd have to do long division, and we're not doing that right now.
Oh, okay, so it only works if you have the...
It only works if it's like this.
Oh, okay.
I'll do without my calculator here just to show you don't have time to calculator. But oh, I did that wrong already.
Yeah.
We don't need a calculator.
I got it. It's just -27 times 3 is -81, and then 9 times 4 is 36, and then 18 times 3, -3 is plus 54, and then -3. So then that's negative. -84 plus 5, 6, 7, 8, 90. So 6. Did you get 6?
Sure.
You should check my math. You know I'm wrong all the time.
Yeah, so you're right.
I always group my negatives together and my positives together to make things easier when I'm doing this, because that's the commutative property that says I can rearrange the order, right? So since I got 6 as my answer, is this a factor? No.
No.
What am I going to plug into this one?
3.
+3. It's the opposite sign of what's there, and that's the big thing you have to know, that it's like this is the 0, that's the factor. So if I plug 3 in here, I would get 27 minus 9 minus 3 minus 15.
Yeah.
Oh my gosh, it's finally 1.
So this means yes.
Everybody thinks I'm stupid.
I got you.
Wait, did the microphone pick up our wrong answer?
Probably.
I don't know. We'll have to see.
I hope so.
Wait, no.
I mean, I'm not going to watch the recording because I know what I'm doing.
Why'd you look at me when you said that?
Yeah.
Because you were doing the -6 and -4 thing, and you were like, no, it's still wrong.
So we did this the other day about writing a polynomial from the zeros, and here's another one. So again, probably you can guarantee you're going to see one of those on your test. This one says find a polynomial function with a leading coefficient 2 that is degree 3 and has zeros at -1, 3, -5. When we did last week, we said using only algebra. I don't know what else we used, but
Precalculus.
Yeah.
it's just algebra though.
It just happens to be out.
Any ideas?
No.
I'm just going to start with y equals. You got to do that. If you're writing a function, you got to write y equals or f of x equals. What do you know if you have a 0 at x equals -1? If I want to go backwards, what was it before I got x equals -1? What was the factor? Is that the same as saying x plus 1? So if they give me the zeros and I want to write the polynomial, I just have to go back to the factors.
Yeah.
So if 3 is a 0,
-3, x minus 3.
the factor is x minus 3. And if -5 is a 0,
Why does this thing sound like it's spewing out gas?
Because it is. We're all going to die.
did I meet the requirements of what this is asking me to do?
2, just 2.
2 to the
Because if you had 2x, it would be 2x to the 4th. It would be x to the 4th, because it would be 4th. I'm smart at the party. No, I'm afraid these
Confidence is key.
And then you got to work it all out.
Yay.
It really doesn't matter in what order you do this in, so I'm going to just say 2x plus 1. Yeah, just kidding. 2x plus 2. And then I'm going to multiply these two out together. Can I do that? So I'm going to FOIL that. So I'm going to get x squared, and I'm going to do that in my head. 5x minus 3x gives me plus 2x in the middle, and then minus 15. 5x minus 3x. The OI. Now I have to do this again. This is not FOIL. This is just a bunch of distributive property.
Great, do it again.
So I'm going to say 2x cubed plus 4x squared minus 30x. And then I have to give this 2 to everything. So then I say plus 2x squared plus 4x minus 30. Am I going to leave it like that?
No.
No, I can combine my terms, right? So 2x to the third, and then I have a 4x squared and a 2x squared, so that's a plus 6x squared. I have a negative 30x and a plus 4x, that's a negative 26x, and then minus 30. So I have degree 3, leading coefficient of 2, and that has those 3 zeros.
Yay.
Definitely going to have to do that on your test.
Of course we are.
Yeah.
Let's take a few more notes.
Everybody is doing that. Can we just do more homework and stuff?
No.
I'm going to take a little bit more notes. We're not going to be here tomorrow. We're going to take more notes today.
That is true. It's
Teach us.
Oh my gosh!
Yeah, she said that in the class.
I'm an academic team.
Oh, that's okay. Never mind. I remember this now.
I don't listen until you actually start teaching.
No, okay. Here's what happens. I listen, but I forget really quickly.
You're just like my Aunt Lori, and she's like 57. What about
Okay, so the point of checking zeros and factors, and I think, how many questions did you do on your homework? 4?
I did 5, 6. I think I did 6.
You said you did it all, you liar.
No, I said I did 1.
I think there were 8 questions, and I told you to do the first 4, and then there's 4 more about is it a factor, checking the remainder theorem, is it a zero, probably pretty quick to do because you don't have to do division now.
I blame Star Wars.
And then the point of that is to get to this. This looks really scary, right?
Yeah, pretty scary.
Sure.
But this says if you have a polynomial with integer coefficients, you can find a list of every rational zero by taking the factors of the constant term over the factors of the leading coefficients. And I call those PRZs, possible rational zeros. Do you have any recollection of that from Mr. Gressick?
No.
Yeah.
Where you list out all the zeros like plus or minus 1, plus or minus 2, plus or minus 1/3, plus or minus 5/3.
We acknowledge the problem might have been a little further back with Mr. Weiler, too.
Yeah.
This has nothing to do with Mr. Weiler. He did not teach you this. This is why
He didn't teach us much of anything.
Nobody.
this is why we normally give geometry to the new teachers, because the new teacher can screw up geometry, but it doesn't affect the other math classes. But algebra 2 is very important to go to precalculus. So last year we had to have a new algebra 2 teacher and a new geometry teacher. So
Sorry.
back to normal programming.
Sorry that sucked.
Technical difficulties.
Mr. Guzzick's like, what? Major Walk, you can tell this is an F because of the way it is.
Okay, so you need to write out to find possible rational zeros, aka PRZs. You have to cry a little bit, and then you're going to take factors of the constant term divided by factors of the leading coefficient.
He left his emotions at home today. Just brought his sad with him. No, Arnold Palmer died, and it's
I did hear
it's
the
screwed
Arnold
up.
Palmer. I really struggle with that name.
Palmer.
Arnold
So did,
Palmer.
What was his name?
Arnold.
Jose Fernandez.
Yeah,
So,
Jose
like,
Fernandez.
Jose
died, too.
Fernandez. I did. He's some baseball player.
Yeah.
Died in a boating accident.
Picture.
Yeah.
He hit a jetty
Yeah. On a boat.
on a 70-foot boat.
Am I the one
He died.
Yes, all the other
And,
girls left.
Along
No,
with
really.
some other people. Yeah, but we only care about him.
Okay, so here's what you have to do. If we did not have possible rational zeros, hello, I'm not gonna be here tomorrow. You gotta know how to do this. We have a test this week. You gotta know how to do this. If you did not have PRZs and I said find the zeros of this function and you didn't have Desmos, which you won't have here on your test, you would have to just start guessing numbers. Like just start guessing random numbers, which is really a lot of numbers to choose from. So this is why PRZs are really, really helpful to us. So it says use the PRZs to write a list of potential or possible rational zeros, then determine which ones, if any, are zeros. Again, I know what's out there that you can find the answers immediately by using Desmos or something, but again, be aware that on your test you get nothing but your brain and your pencil and a scientific calculator. So don't be using Desmos and thinking like this is so easy and then get to the test and just cry because you don't have Desmos. Okay? So, PRZs, it's factors of the constant over factors of the leading coefficient. So what is the constant in this problem?
Negative 14.
So I'm going to write out a lot on this one because it's the first one. I'm going to say factors of negative 14 over factors of the leading coefficient, which happens to be 3. And then you have to write out all the factors of 14. 1 to 14, 2 and 7. But remember that they could be plus or minus, because they could be negative 1 and positive 14, or it could be positive 1 and negative 14. So we always just say plus or minus. So factors of 14, I'm going to say plus or minus 1. And I like to go in order, but you can say 1 and 14, but my heart just won't let me do that, all right? So I say plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14.
Do we have to put plus or minus in front of all?
Yes.
Or can we put
Yes.
plus or minus
No.
parentheses?
All of them. All of them.
Alright.
And on the bottom, factors of 3, plus or minus 1, plus or minus 3.
You said plus or minus 1 as I was writing plus or minus 3, so I put plus or minus 13.
And then we have to think of all the possibilities of what numbers these make. So the easy one is we could put all of these numbers over 1, right? 1 over 1 is just 1, 2 over 1, 7 over 1, 14 over 1. So they're just all the top numbers. So we could have plus or minus 1, plus or minus 2, plus or minus 7. Oh my goodness.
Oh my god.
Plus or minus 14. But then we have to go back and we have to put them all over 3. So 1 over 3 is just plus or minus 1/3. 2 over 3 is plus or minus 2/3. 7 over 3 is plus or minus 7/3. And 14 over 3 is plus or minus 14/3. So we went from an infinite amount of numbers to check to just 2, 4, 6, 8, 10, 12, 14, 16. Only 16 numbers. As opposed to infinitely many numbers.
Let's try 14.
So it says, this is the fun part, then determine which ones, if any, because maybe none of them work, if any are zeros, which means you could do synthetic or long division for every single one of these.
No.
But you should not, which is why we have the factor and the remainder theorems, because we can just plug these numbers in until we get 0. So I always have a hope that 1 or negative 1 works, because I can do those pretty easy. But you can have a hunch. You can be like, I feel like it's 14. I feel like it's 7/3. I don't care which ones you pick. But I always start, and I just go and see what happens here. So here we go. I'm going to plug in 1. And if I plug in 1, I get 3 minus 7 plus 6 minus 14. And all I do in my head is I don't even care what it equals. I just care if it equals 0. So like in my head, I'm like 9. Nope. The negatives are bigger than the positives, right? So I'm like, eh.
One down.
15 more to go. Then I'm going to pick -1. Again, there's no rhyme or reason of this except for I just like 1 because it's easy for me. If I plug -1 in, I get -3, -7, -6, -14. Those are all negative now, right? Does that tell me anything about my numbers? Should I pick any more negative numbers right now? Because when I pick a negative number, all the signs turn negative. So that's why I think it's worthwhile to take a minute and not just type on your calculator. Because you can see it's just getting more and more negative. So it doesn't matter. I've just eliminated half of my choices now. Because I'm not going to check any more negative numbers.
Yeah.
Follow me on that?
Goodness. So now we only have 7 more.
7 more!
And 4 of them are fractions.
So, we should teamwork this, and everyone should take it, right? Too bad you can't do that on a test.
Yeah, why not?
Yeah, we can't do it here. You got it.
Yeah, we could do it on a test. You got it.
Thank you for copying Christian.
-6. I got -6 there. I'm thinking it's a fraction.
I'll help you out.
Try the fractions.
Oh, fractions? Oh, I'm not helping her.
Oh, I'm just kidding. I'm done.
You're gonna have to do this on your homework, kids.
Yeah.
Yeah, that's all.
Yeah.
Oh, and this was 714. I'm not checking, since 714, I'm not checking 14. So I'm gonna check 1/3.
Or I'm doing 1/3.
Okay, I'll check 7/3.
Seven.
You just do parentheses, and then you can just type your fraction in. -7 times 7/3 squared plus 6 times 7/3 minus 14. It was
Oh.
Nice sound.
was
We
exciting.
definitely do not get a 0. Or 1/3. We get -12.6.
Okay, so here are some options. One option is when it only says find all the ones that work, you still have to check the ones we haven't checked yet. But I think it makes way more sense that once you find one that works, divide it out and look what's left, because you're going to have to do that soon anyway, like later on in the notes. So when I find one that works, I know that works, so now I want to divide it out and see what's left. And this is where you can do long division if you want, but I think synthetic division makes way more sense. And yes, I'm going to do synthetic division with a fraction. I need more room. Okay. So I'm going to take 7/3 and I'm going to divide it out. I don't have to change the sign because it's already like the 0. It's not factor. And I'm going to divide it out of here. And I'm going to say 3, -7, 6, -14. I already know that I got a remainder of 0. So if I do this and I don't get a remainder of 0, either I screwed up over there or I screwed up over here. And you have to find where you messed up on a test, which is the tough part. Sean, you don't stop. You don't have to check anymore. I'm showing you a better way.
He's like, but I only have one left.
So I'm going to bring 3 down. And 3 times 7/3 is
21/3. That's 7.
7.
Yeah.
Because the 3s are going to cancel out. And then -7 plus 7
0.
is 0.
So nothing. 6.
And then 0 times 7/3 is 0.
-14. Well, that'd be 6. That'd be negative. No, that'd be 14.
It would be 14 because the 6 and the 3 would divide to get a 2, and 7 times 2 is 14. So it kind of checks that that did work. So here's why I think this is better. Nobody, right? Nobody wanted to help me but Sean to type all these numbers in. If you divide it out and look what's left, you can see if you can solve that. It's hard to solve a cubic, but look what's left now. I'm left with 3x squared plus 0x plus 6.
Wow.
If you tried to solve that, is it going to be a nice number or it's going to be a not so nice number? we would get -6. We would get x squared equals -2. We would get an imaginary number, right?
Ah, screw that.
Eventually, we're going to want that answer, but right now, it just wants the rational ones, which means if this is not a nice answer, we don't need to solve this, and we know that 7/3 is our only answer. So the only rational zero that works is 7/3. Then we would get our other answers, and they'd be from our list there.
14/3 went out to 166.4 repeating.
It doesn't work. I know. This is my proof it doesn't work, because it's imaginary. The other zeros are plus or minus I radical 2. Let's do one more, and then I'll stop. And then that means tomorrow I'm going to do the rest of these notes for you while I'm not here. And then you're going to do the rest of your homework. But you can do some of it tonight. Find the rational zeros. So step 1, I'm going to do my PRZs. These are your steps. So factors of 9, plus or minus 1, plus or minus 3, plus or minus 9. It's super great when the leading coefficient's 1, because that means you don't have any fractions to check, right? But it's not. Plus or minus 1, plus or minus 2. So we have plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 1/2, plus or minus 3/2, plus or minus 9/2. If you ever do the fraction and it happens to work out to be one of the other numbers, like let's say that was 8. 8/2 is 4, and if you already had 4 listed, right, you don't have to list it twice. It's the same number. But all these are all different. And then the tedious part, the part that you don't want to do, but you have to do, is you have to just plug numbers in until you find one that works. But again, really nice, if it's a cubic, as soon as you find one that works, you can divide it out and get a quadratic, and then you don't have to guess and check anymore, because we know how to solve quadratics. So I'm going to have a hope. Does 1 work? 2 minus 1 minus 9 plus 9. Does -1 work?
No.
-2 minus 1 plus 9 minus 9.
No.
Oh, so close. Oh. And then I just go to my calculator. $27 did not work.
No.
So I'm gonna try -3.
Oh.
What?
I couldn't even hear this.
I just got -27 when I did -3. Does that make sense? I feel like I'm working way harder than you're working.
Bad notes.
Yes,
No.
yes, you are.
Nice.
I got stuck in the queue.
You don't know how. You just do it on a calculator. All right, I'm just jumping to fractions. I should have had this worked out so I could just be like, it's 1/2. I don't know.
You should check 1/2 if it's 1/2 your god.
Goddess.
Goddess. Whatever.
Okay. 9 does not work.
1/2 does not work.
1,300.
What about 3/2?
What's really great is on these calculators, you can go back and just change the numbers if you type it in nice the first time. Like, it really makes your life easier. And if you were actually doing it right now, I could show you.
I'm doing it!
You're the only one.
Listen, I hate those calculators because I...
-1/2 doesn't work either.
Take actions. Stop it. This is the calculator that I had since like the year 8.
Which one are you doing this time?
I do it.
3/2.
Yes.
3/2 works.
Positive 3/2.
And this is the part, as you do the homework, that you have to practice doing this. During a test, if you come to me and you say, I checked them all and they won't work, I'll say, you're doing something wrong on your calculator. It is a test, and I can't help you, but I can help you before the test, which is why you should be doing it. So I'm going to stop checking. I've almost checked all of them. But I'm going to divide this out now. And again, it should give me a remainder of 0. 2 times 3 halves is just 3. 2 times 3 halves is just 3. Negative 6 times 3 halves is negative 9, which gives me that remainder of 0. So what I want to look at is that quadratic that's left, 2x squared plus 2x minus 6, and I want to see, can I solve that? So since it's all divisible by 2 and I'm setting it equal to 0, can I just divide by 2 there? Sure. And I can say x squared plus x minus 3 equals 0. Can you factor that with nice numbers? Are there any numbers that multiply to give me negative 3 that subtract to give me 1? What's the only two numbers that multiply to give you 3?
1 and 3.
Can you subtract 1 and 3 to get 1?
No.
Which means this is either irrational or imaginary. Either way, it's not rational. So if it asks you only for the rational zeros and you get down to something that's not factorable or it's not a real number, you don't have to keep going unless it says find all the zeros, okay? So this is not factorable, which tells me that I don't have to pick more of my numbers here. So the only answer is x equals 3.
So if it is factorable, that x equals that's another 0.
Yes. So if it's factorable, you might have 3 rational zeros here. Because if this was factorable, let's say if this was a 2, we could have factored that into 2 and 1, and we would have had those answers as well. Okay? So I want you to finish the homework from Friday, which there are 8 questions. I asked you to do the first 4, so you should be able to do the other 4. And then I've also put on 2 for day 2. You don't have to do all of it. You actually could just save. There's only 6 questions there, but I think you could probably do the first couple. This one says what are the rational zeros? They give you a graph to help you, but PRZs. The second one says what are the possible rational zeros, and then the second part asks you which ones work. So I think you could do the first 3 questions if you really wanted to, but tomorrow I'm going to leave a recording for the rest of these notes, which you have a copy of, so don't lose them. I'll leave a few extras if we need to. I'll finish the notes, and you'll have to finish the homework. And then Wednesday, we will start reviewing. Wednesday, Thursday, we will review. Friday, we will have a test.
Perfect.